Let E be an event on the sample space S. In this tutorial, I'm going to show that the probability of E complement is equals to 1 minus the probability of E. So we are given that information there. What I'll try to do is I'll try to find an equation which links the event E to its complement. We know that when we take the union of an event and its complement, we get the universal set. In this case, our universal set will be the sample space, the set of all possible outcomes. So we would have that the sample space is equals to A union A complement. Taking probability on both sides, then we would have probability of S is equals to probability of A union A complement. But looking at the left-hand side, we have probability of S, the probability of the sample space. By definition, we know that the probability of the sample space is equals to 1. So put 1 here, and we would have 1 is equals to probability of A union A complement. But now looking at the probability of A union A complement, we can use the formula for the probability of the union of two events. If we have events E1 and E2, the probability of E1 union E2 is equals to probability of E1 plus the probability of E2 minus the probability of E1 intersection E2. So if we use this formula here, apply it on the highlighted part there, what we would have there is 1 is equals to probability of E plus probability of E complement, probability of E intersection E complement. I just replaced where we get the E1, I replaced with E, then E2 replaced with E complement in this formula here. So I'll now move on to the next step, looking at the probability of E intersection E complement. And the intersection of a set and its complement gives us the empty set. So for that highlighted part there, we would have the probability of the empty set. So our equation becomes 1 is equals to probability of E plus probability of E complement minus the probability of the empty set. So we now go on and evaluate the probability of the empty set there, or the probability of the empty set by definition, and that will be the cardinality of the empty set divided by the cardinality of the sample space S. An empty set is a set with no elements, so its cardinality will be 0. So we have that the probability of the empty set will be 0 over the cardinality of S. 0 divided by the cardinality of the sample space there, it will just give us a 0. So we are having this part here is a 0, so our equation becomes 1 is equals to probability of E plus probability of E complement. And then go on and just rearrange this equation, and then we have probability of E complement is equals to 1 minus probability of E, which is what we were required to show.